Yeah. So welcome back, guys. This is Madhav PVL, and today we are going to discuss about perceptron computer vision. So let's get started. So I just made a notes regarding this, and also I'll just try to make another video which is regarding sums, and I also missed some concepts in this video. So I'll just make sure I'll do that again in the another video if possible. But these are the very basic concepts which were really essential for the exam. Without these you can't just even attempt the paper at any cost. So that's the reason I'm just making this video as quick as possible. So please subscribe to Works After College, also share with your friends. So let's get started. So now perceptron vision computing. So firstly, when we come to CO3, the first topic we see is the morphological operators. So what is morphological operators? So it is nothing but these operators are used for the purpose of removing the imperfections in an image. So removing the imperfections in an image in the sense there may be some noises and all those stuff. So to remove these things we use morphological operators. So it is a range of image processing methods which deals with the shape and features in an image. It is implemented to remove the imperfections in an image. So now let's go to the next one, structural element. So structural element will have three conditions, that is fit, miss and hit. So now what is structural element? So it is a small which is used to probe the image. So probe the image is nothing but to just optimize, to just develop the image in a proper way. For each structuring element we should define the origin. So origin is nothing but we can just say like, so this may be the origin or this may be the origin, or any one element can be the origin. So the shape and size must be adapted to the geometry. So now if we just see here, so this is a SC, so this is a structural element and this is the image. So if we just consider this is the first layer of the image. So if the structural element is matching towards the first element, then it is a fit. So everything is getting matched here. So this will be a fit. Whereas in this only the first element is getting matched with the image. So first in the structural element only the first pixel is matching with the first pixel of the image, then it will be a hit. So none of the pixels are matching with this image, so this will be a miss. So these are the three conditions where we can see in the concept of structural elements. So dilation and erosion. So dilation enlarges the foreground and shrinks the background, whereas erosion shrinks the foreground and enlarges the background. So for any image there will be two concepts which are named as foreground and background. So with the help of this dilation and erosion we can just play with those images. So we can just make cool stuff with the help of this dilation and erosion. So let's just know what is dilation. So it is a set of all points where the structuring element touches or hits the foreground. So here we had just said like it enlarges the foreground, here it enlarges the background. Foreground in the sense the place where the objects are mainly focused, the main person in an image will be there, so he will be the foreground, and the background is nothing but the place where he stays or where he took that photo. So it is a set of all the points where the structuring element touches or hits the foreground. Consider each pixel in the input image. If the SC matches completely or at least one element, write one at the origin. So one at the origin is nothing but so we can just say like, if this image is completely written, so here we can just say like, if this image is completed, so here we are having all the elements. So if we just match one of this with this, then here we can just mark 1. So with this we can mark 1, with this we can mark 1. So in this way, if we match everything, we can just write some other table and we can just match this whole thing with this one, like this will be considered here and now the below one, and we can just consider that, and we can just check out whether it is fitting or hitting or missing. So in this way we can just mark one at the origin in the sense the way in which we consider as the first element in an image. So don't get confused, it's a very basic thing. So applications are, it repairs the breaks in an image, repairs intrusions and enlarges the object. So you can just write this in an exam. So dilation is denoted with this A plus of B, and then erosion. So if the set of the points where the SC elements completely fit into, then we can just consider the foreground pixel in an input image. If the SC completes completely fits the image, write 1 at the origin. So this will play a major role with the background, and this will play a major role with the foreground. So if it is completely mixed up with the foreground, the SC is completely mixed up with the foreground, then we can just return 1 at the origin. So this is a concept of erosion. So applications are split and joined objects, strip away extrusions, or shrink the objects. So erosion is denoted with this thing. So example prob, so here we can just say like, so this will be the image and this will be the SC, and then if we just add this to this whole elements, like we'll just add this with the whole thing and we'll write it here, and we'll just add this whole thing with this and we'll write it here. So after writing this both, we can just consider the union of this both, union in the sense the common elements can be returned once here. So after writing the union of this both, we can just say like the erosion of A is this. So yeah, so we can just say like the erosion of A is this, because this will be the union of the both and this will be the intersection of the both. I mean, first we need to just separate the things here. So here we can just say like 3, 4 should be, so here this is the image and this is the SC. So we need to separate this with this and we need to write the erosion. So 0 of 2, 1, 1, and we can just write this. So 0, 1, 0, 2, 1, this will be 1, and 1, 1, 1, and 2, 1 is 2, 0, and this is 2, 1. So in this way we need to separate the things and we need to add the things. This will be the union and this will also be the union, but we need to just separate the things here to get the erosion value. And what is DWT transforms? So DWT transforms are nothing but the way in which the wavelets are discretely formed. So a key advantage in temporal resolution, if can capture both frequency and the location info, DWT provides a simultaneous spatial and frequency domain info. So these are the definitions where we need to just write them in exam. So Haar wavelet transform. So it is developed for constructing bi-orthogonal wavelet. It doesn't depend on the Fourier transform. It becomes a method to implement the reversible integer wavelet transform. So two types of coefficients are obtained, like coarse approximation of speech calculated by the average, and this is calculated by the subtraction, fine details of the speech. So two types of coefficients are obtained in this Haar wavelet transform. So average is nothing but the summation of, so I will just discuss this in the example. So Haar wavelet transform is nothing but it is a method which is used for the implementation of reversible integer wavelet transform. So it allows faster implementation, very efficient for real time low power, can be used for irregular sampling. So now we will discuss this both in the below sum. So scaling coefficient, all to adjacent and divide by the 2, subtract to adjacent sample divided by the 2. So this 2 has been returned here, and then here we can just see. So this will be the set, the image. So this will be the image. So if we try to just find out the first one, that is scaling coefficient, adjacent of 2 and divided by 2. So we need to just make sure like the elements are of 8. So if there are not 8, then we need to just add a 0 at end. So these are 8, so there is no need of 0. So if we just write those 8 elements here, we need to just divide them into 2 group. So 2 of group we can just divide them, and we can just add those both and divide it by 2. So 2 plus 2, 4 divided by 2, 2, 2 by 2, 1, 8 by 2, 4, 4 plus 4, 8, 8 by 2, 4. So in this way we will just divide this whole thing and we'll just make it like this, and then this is nothing but x minus y by 2. So 2 minus 2 is 0, 0 by 2 0, 0 comma minus 2 is minus 2 by 2 minus 1. So in this way we will subtract and write it here, and here again we need to just write the resolution. So these are of 8 elements and these are of 4 elements, and after completing this step we will get 2 elements, and after that finally we will get 1 element. So we need to just write the values here, like we need to just start from here, we need to write this and we need to write this whole things. We need not write this because from this we find out this differences, right? So we need to just write only these values, like it should follow like this. So we need to write the differences in whole in one place. So if we need to just get back the images back from this, we need to do this. So we need to write it like again in the same position. So we need to just write it like this, and we need to maintain the same structure where it is here. We need to just write it down like this. So 2.75 will be the first one, and minus 1.2 will be this, and 2 here, and remaining 4 here. So in this way we need to write the above structure here also. So after writing that, we can do like, so we need to just add this both and divide it by 2, and again we need to just add this both and divided by 2 and all those stuff. Most probably they will just ask the way in which these things are done, scaling coefficient and wavelength coefficient. So this is actually not necessary, but I just watched some video and written the stuff. Actually I'm not having a bit clarity regarding this, I just forgot. So okay, now let's get to the next topic. So that is Diabachi's wavelets. So it is based on the use of recurrence relations to generate a progressive finer discrete samplings. Most notably, it is used for signal coding to represent discrete signals in redundant form. So this is a concept. So DWT has gained widespread acceptance because of multi-resolution nature. So that's the reason there is no use of this Diabachi's wavelets. So Huff transform. So Huff transform is nothing but so this is very easy. So it is a general technique for feature detection. So basically this is a concept where we can just check whether the line is in the same plane or whether there is any intersection in between those points. We can just check out this stuff with the help of this Huff transform. So currently it is used for the detection of straight lines. There are some other variants for this concept where we can just check out the remaining shapes if required. So here we can just see other variants which can detect other shapes. So let's get started with the example. So if we just consider these 3 points, so question will be like find the Huff transform for this 3 points or whatever may be the question, but I'm just explaining you the answer. So the equation is y equal to mx plus c for a straight line. So this will be an equation for a linear equation, so basic linear equation. So we need to convert each point into m comma c. So m comma c is nothing but the things which were used for the formation of lines. So here we can just consider this first point 1 comma 1, and we need to just substitute the x comma y values in this. So 1 comma 1 is equal to m into 1 plus c. So this will be 1 is equal to m plus c. So we need to consider the c is equal to 0 and we'll get the value of m, and we need to consider the m is equal to 0 and we'll get the value of c. So we need to just consider these both values. So this we got with the help of this first point, and we need to consider the second one. So 2 is equal to m into 2 plus c. So that is 2m plus c is equal to 2. So here we need to consider c is equal to 0. So 2 is equal to 2m plus 0 where m is equal to 1. So m is equal to 0, 2 is equal to 0 plus c where c is equal to 2. So we need to consider this both values 1 comma 2. So in this way we need to do for the third point also. So we will get 3 m comma c values. 1 comma 1, 1 comma 2, 1 comma 3. By watching this with our bare eye, we can just casually think like this stays in a same plane. Actually out of our knowledge we can just say like this stays in a same plane, but we need to just prove it, right? So for proving it we need to just mark out the points. So 1 comma 1 will be here, and 1 comma 2 will be here, 1 comma 3 will be here. So instead of that we can just draw some lines like this: 1 comma 1, 1 comma 2, 1 comma 3. So after doing this we'll get some intersection. So as these three belong to the same plane, we get 1 comma 0. So obviously we'll get this as an intersection point though. So this is not the accurate graph, but if we just draw with a scale we will get all the intersection points here itself. So same plane we get 1 comma 0. So hence y is equal to mx plus c. We need to substitute these values here. So we'll get x is equal to y. So if we got x is equal to y, then we can say that the above points are collinear. So if we just get some another equation, we can just say it as another one, but if we just get like this, we can say this as a collinear. So Huff transform is a popular feature extraction that converts the image from Cartesian to polar coordinates. So scale invariant feature transform. So it is an invariance to image scale and rotation to detect corners, circles, blobs, etc. So it follows a procedure. So scale space extreme detection, key point localization, orientation assignment, key point description, key point matching. So this is a procedure, so I'll just explain it step by step. So let's know this step by step. So scale space extreme detection. So scale space extreme detection is nothing but So it will just consider a pixel here. So it will just try to check out that pixel. Once the image is blurred, so the pixel is compared with the 8 neighbors. So it will just compare first with the 8 neighbors. So then if it is matched, then it will compare with the next 9 and 9 previous pixels. That is nothing but the pixels which are above this particular pixel and which are below this particular pixel. So each pixel will be considered as 999 units. So it is a local extreme, then it is a potential key point. So if it is able to match this all things, then it will be a potential key point. So this whole thing will get blurred. So key point localization, if the intensity of the extreme is less, then threshold it is removed. So here if we just consider this, so if this is matching with only few of the other pixels, then that is less than that of the threshold value. So threshold value is nothing but so basically this technique will have some basic ideology like these many should be similar for making a perfect blurring effect. So if these values, if these are matching with the values which were less than that of the threshold, then it will just remove it. Removal of the edges and low contrast key points is done. So we can just say like for any image the edges are similar. So like this, if it matches like this in this format like this, so it will just consider like these are matching edges, so it will just remove those. Like for that reason also this key point localization. So orientation assignment is nothing but it is assigned to each key point. Highest peak in histogram and a peak above 80% creates key point with same localization and scale but different direction. So it's nothing but it will just try to make a histogram like how many pixels are getting matched. So the highest number of pixels will be considered and the blurring effect will be occur to that. So highest peak in a histogram and a peak above 80%. So for all those things, so highest peak in the sense the most number of repeated blurred pixels and also the pixels which were repeated by more than 80%. So those both will be considered and it creates a key point with same location and scale but different direction. So key point descriptor and key point matching. So they are vectors of size, number of key points into 128. I don't know why it is 128, but yeah. So matching is done between two images by identifying the nearest neighbors. So in this way the edges are removed and finally the image will be there at last, and finally they will just project the image, so with the blurring effect at the background. So that's all about it. And difference of Gaussian. So after creation of a scale space, we must amplify them using DOG. So DOG subtracts the higher blurred version of an image from the lower blurred version. So once pixel is blurred, it is compared with 8 neighbors, then 9 neighbors. So DOG is nothing but this step. So in scale space extreme detection, we need to write the concept of DOG. So that is about DOG. So advantages of SIFT is features are local, so robust to occurrence. Individual features can be matched to large database, close to real-time performance. So expectation maximization algorithm. So I think this is most famous question. I think even in the important question list it is given. So expectation maximization algorithm. Since we don't have values for not observed variables, the EM algorithm tries to use the existing data to determine the optimum values. So here we can just say like expectation maximum is nothing but if the lines are discrete, like we can just say like so this is a complete image. So what happens if it is like this? So if it is like this, we can use the concept of expectation maximization algorithm. So while using this algorithm, we will be given with a set of incomplete data just like this. So it starts with the initializing parameters. So expectation step. So expectation step is nothing but it will just guess the input for that empty spaces. So it will just try to draw some lines and some random stuff, and it will just try to determine the place in which where we can just complete that whole data. So it will just try to complete that incomplete data, whereas maximization step is nothing but by considering those guesses, we need to just complete the data, complete those parameters. So we need to repeat the steps 2 and 3 until we complete the data. So start, initialize the values, expectation step, maximization step. So it is convergent. Convergent is nothing but if the data gets completed, then stop, else we need to just repeat the 2 and 3 steps. So this is a concept. and advantages it is it's pretty easy for many ML props. The solution always exists in closed form. The value of likelihood increases after each iteration. So it is used to calculate the Gaussian density of function, used to estimate the parameters in HMM, helpful to fill missing data during a sample. So if you just understand the concept, you can write those advantages in applications easily. Yeah, so this is image segmentation. So image segmentation, I think most probably we were in CO4, and some of the questions which were not covered in CO3, I will just try to do it at the end of the video. So let's just don't break the flow. So image segmentation. So image segmentation is a method in which a digital image is broken into subparts. These are called as image segments. So it's assigning labels to pixels. So approaches in image segmentation is similarity approach and discontinuity approach. So this approach is based on finding similarity between pixels to form a segment. Discontinuity approach is nothing but based upon the pixel intensity values, lines, points and edges detection techniques. This by using this type of approaches we can find out the segmentation. So these are the two ways in which we can just find out the image segmentations. So there are also some other techniques like threshold based segmentation, edge based segmentation, region based segmentation, clustering based segmentation. So we'll just discuss about them brief in upcoming. So Laplacian of Gaussian log filter. So what is log filter? So log filter is nothing but so there is a rule like a Laplacian filter cannot be directly applied to a image which is having noise. So Laplacian filter should be applied to image where there will not be any noise in that image. So if we need to just remove the noise in that image, we need to use this Gaussian filter. So as we can't use Laplacian directly for the edge detection as it is sensitive to noise, we use it after applying the Gaussian filter. So first Gaussian filter is applied, then Laplacian is applied. So smoothing is done with the help of Gaussian filter. Smoothing is nothing but removal of noise, and enhancing edges is done with the help of this Laplacian operators, and then zero crossing denotes the edge detections. So in this way this Laplacian of Gaussian log filter is done. So log algorithm is apply log to image, use 2D filter, use 410 filters, find zero crossing, find slope of zero crossing, apply slope to slope and mark edges. So Gaussian smoothing formula is S is equal to G into I, where S is the smoothing, G is the Gaussian filter, I is the image. Laplacian is nothing but delta square S is equal to delta square by delta x square plus delta square by delta y square. So this is a second order derivative of x and second order derivative of y. So these are two formulas for Gaussian smoothing and Laplacian filter. So here we can just say like the value of this increases, the smoothing in between the images also increases. So the value is 1, there is a bit smoothing. So value is 2, the smoothing increased. The value is second order derivative of 1. So here we need to consider the negative coordinates also for the second order derivative. So when a value increases, the smoothing also increases. So dog, difference of Gaussian. So I had just explained it previously. So it is calculated the differences between the two smoothened version of the images obtained by two Gaussian kernels. So it is worked by performing two Gaussian blurs with the different radius and finding the differences. So by performing this whole thing, so the Gaussian blurring thing and with two different radiuses and two different values, we will just find out the difference in between those two and we will just return this. So it may help to know the increasing smaller radius tends to give thicker edges and decreasing larger radius tends to increase the threshold. So it is like so if we just increase the smaller radius images, then it will give thicker edges, and if we just decrease the larger radius tends, it will increase the threshold. So majority of the edge enhancement algorithms commonly employed procedure unwanted side effects of noise. So this is a disadvantage. So histogram of oriented gradients. So histogram of oriented gradients is a feature descriptor for images. We can define an image by its pixel intensities. This works as same as the way in which they detect the edges. So pre-processing the data. So basically in this histogram of oriented gradients, so we need to just, whatever may be the size of the image, but we need to just consider it in the ratio of width into height ratio should be 1:2, like preferably 64 into 128 pixels. So in this shape the data should be pre-processed, because we divide the images into patches as 8:8. So we calculate the gradient. So gradients are small changes in an image. So if we just consider this image, so this is of 1 2 3 4 1 2 3 4 5 1 2 3 4 5. So it is of 5:5, and if we just consider this pixel, for calculating the gradient in the x direction is nothing but this direction, and this will be a y direction. So calculate the gradient in the x direction, we need to subtract this with this. So the right one with the left one. So 89 minus 78 gives you 11, and for this also the same, the top one and the bottom one. So 68 minus 56 gives you 8. So this is a gradient in x direction, and this is a gradient in y direction. So we need to calculate the magnitude and orientation. So total gradient magnitude is nothing but square root of gx square plus gy square. So 11 square plus 8 square root gives you 13.6. And calculate the orientation is nothing but tan of 11 by 8. Tan of 8 by 11. So that gives you some other value. So we need to calculate the histogram of gradients in 18:8 cells. So histogram is nothing but, we need to just write this concept in the exam, but basically if we just get into the Python code, so it will just try to locate the most of the major parts in that particular image. So most of the major elements and which were very important, which were required for that particular image, will be represented with the help of a histogram. So normalized gradients, so some parts of the image may have high brightness, but it can't be negligible, so we can consider it as 16:16. So if we just consider 18:8, some of the pixels may look bright, so we may just remove them, thinking that as a miscellaneous. So we can just consider it as 16:16 blocks for reducing the lighting variation. So finally the features of the H4G can be created. It may have 105 blocks, vector in 36:1, so the total features are 105 into 36:1, that is 3780 for that above example. So these are some of the important questions in CO4. So how is KNN different from K-means clustering? So KNN is a supervised learning algorithm, whereas K-means is an unsupervised learning algorithm. So its aim is classification or regression. Its aim is grouping of similar data points. So this algorithm is trained for labeled data. This is trained for unlabeled data. So this is of small data sets, and this is of larger data sets. It is expensive, it is not expensive. So these are the differences in between the KNN and the K-means clustering. So what is cluster sampling? So cluster sampling is a technique which is used, we can just say like, if in a ground there are both male and female standing together, we need to just make a cluster sampling. We can just reduce male and female on base of their gender. So this is a process of dividing a group of people based on different characteristics. Once the clustering is done, a subset of that can be done. So advantages, it is less expensive and more efficient for large data set. It can reduce the potential for bias because clusterings are randomly selected. So it may increase the sampling error because of similarity in subsets. Sometimes some characteristics may be same for boys and girls, so there may be some sampling error and all those stuff. So limitations are nothing but the disadvantages. So define grid based method. Grid based method is nothing but, it is just drawing like boxes for an image. So we can just say like for every Python experiment we will be getting something like boxes, dividing the image into some segments. This involves dividing the whole into subcells and finding the solution. The concept of approximation also occurs in this concept. So these are easy to implement, efficient for large size grids. This can easily parallelize it. So this is prone to numerical errors in the grids. If it is not designed properly, they may not give high accuracy. So list of applications of clustering. So customer segmentation, image segmentation, document clustering, social network analysis. So customer segmentation is, as I said before, clustering of customers based upon different characteristics, whereas image segmentation is nothing but based upon their similarity, the images get segmented, and document clustering is nothing but the same context of documents will get clustered, and then social network analysis is clustering of social media groups based upon their posts and interactions. So what is dimensionality reduction? So dimensionality reductions is nothing but reducing the time complexity of that particular algorithm. So it is process of reducing the input variables data set in an algorithm, but trying to get the same output as much as possible. For this, there are two approaches, like feature extraction, feature selection. So feature selection is nothing but the process of selecting a subset based upon their relevance and target data. This is possible when there is a larger data set, whereas feature extraction is nothing but it is a process of transforming the original feature into reduced feature but expecting the same output. This is possible when there is no clarity regarding the feature set. So big questions, we need to learn what is K-means clustering algorithm. So K-means clustering algorithm is nothing but it is an unsupervised learning algorithm where it creates K clusters for a set of unlabeled data. So here we can just say, like if we just select the number of K, decide the number of clusters, we need to select random K points, assign each data point to their closest centroid. So it is nothing but so if you just consider a graph like this, so there are some data points here and also there are some data points here. So if we just try to draw a line here, we need to consider this as one cluster and this as one clusters. The forming of clusters will be done based upon different characteristics and all those stuff. So calculate the variance and place a new centroid. So I think we know this in AI, so we studied this in a previous semester. So give the conditions for perfect transform. So perfect transformation is nothing but reversible transformation. So if we just transform our image into another image, so we would be we should be able to transform that back into that original image. So that is a reversible transformation, and no info loss is nothing but if we just transform image into another one, there shouldn't be any data loss. So no distortion is nothing but the image should be faithful without any distortion, like no additional noises should be involved in the transformation, and linearity is nothing but the transform should be linear. So what happens if you apply multiple transforms to an image? So if we just apply multiple transforms to an image, we can't just guess the output. So the output may be complex, so we can't just guess the output. Generally the order in which we apply the transforms makes sense, so it makes a proper prediction. So if we can able to remember the way in which we applied those transforms, we can just predict the output. So define surf, speed up robust features. So speed up robust features is nothing but it is a feature detection and description algorithm used in image processing. So it extracts the robust features from an image which will be able to recognize the objects. So algorithm detects the key points in an image. Once the key points are detected, it will be able to write a description for that key point. So this is about surf, and I'll just try to make another videos with the concepts which I had missed in this particular video, and also some problems. Thank you for watching. Please subscribe to Works After College. Also please share with your friends.